Hello, I am Shubhakar Nayak G, lecturer in Polymer Technology, Karnataka Government Polytechnic, Mangalore. On behalf of Department of Collegiate and Technical Education, I am going to present PPT on fundamental of extrusion and extrusion process. This is the third session of Unit 2. Program is Polymer Technology, course Plastic Processing Technology for third semester. Course outcome is the student will understand the basic knowledge of extrusion and extrusion process. Before I begin today's session, let me just glance about the previous session. We had learned about the extrusion of pipes, profile extrusion, extrusion line for cable industry, and film extrusion, that is by blow film technique, flat film technique, sheets and film extrusion, etc. Now in today's session, we will be going to discuss about filament and fiber extrusion, coating and lamination, co-extrusion, and troubleshooting, and basic knowledge or elementary knowledge of reaction injection molding. Then MCQ will be there at the end of the session. First of all, let us look into filament extrusion process. How the plastic filaments are made, what type of machines are used. You can watch this diagram. See, the extruder is the one which is the main machine what we need. Hopper is here, feed material, material is charged here, and the melting of the material and pushing or pumping of this molten material through the die is taking place here. The extrudate is coming out of the die as shown here. The sizing plates are there. This is the water tank, and then the filament goes out. This is the pull rollers through which it is being pulled at the synchronized speed, the speed of the extrudate emerging out of the die. That should match the speed of this puller. Then it is taken out. This is the cut-off machine, and wind-up arrangement is there at the end of the this unit. The entire this is called extrusion line for filament manufacture. Thermoplastic pellets, nothing but the raw material, will be softened, melted, and thus that will be pushed mechanically through a die. Pushing the soft plastics through the die will cause it to form continuous filament or strand with the diameter of the die. This process comes under extrusion. Mostly synthetic and cellulosic manufactured fibers are created by extrusion technique, forcing a thick viscous liquid through the tiny holes of the spinneret to form continuous filaments of semi-solid polymer. So as you could see here, the extruder, cut section of the extruder is shown. This is called spinneret. The material, granular material is fed here, that will be melted in this screw and barrel arrangement. This is the molten material in a green color, that is the molten plastic material, which is coated to this, the material, to the wire or in the form of a tube. It is sent to which onto which this is coated. So this way the coating is done. Most synthetic and cellulose manufactured fibers are created by this extrusion technique. With extrusion coating, an extruder forces the melted thermoplastic through a horizontal slot or die onto a moving substrate. Substrate is nothing but base material. So the rate of application controls the thickness of the continuous film deposited over the web. The melt stream extruded in die, one layer or extruded co-extruded layers can be used as a coating or as an adhesive to laminate or sandwich two or more materials together, such as plastic film, foil and paper. We can make use any of this as a base material, plastic film onto which we can do the coating, or foil or paper even can be used any of any size, that is any width. There are three types of lines. One is a thin film with the low tension applications. So that type of around the tension level is 88 to 80 pound force, and the another type is the combination of the middle range is there, 20 to 200 pound force, and high tension applications, that is the 150 to 1000 pound force. So paper boards usually is a high tension type. You can take more tensile load. So thin range, low tension range, middle tension range, and high tension range. These three types of substrate material can be used for coating. As the melt leaves the die lips, a thin molten film is pulled down onto the nip between the two rolls situated directly below the die. The substrate, which is moving at a speed faster than the extruded film, draws the hot film to the required thickness, while the pressure between the chill roll and pressure roll forces the film onto the substrate. Meanwhile, the molten film is being cooled by the cooling arrangement. Chromium plated chill rolls are used. The pressure roll is also metal but is covered with the rubber sleeves, usually neoprene or silicone rubber. After leaving the chill roll, the coated material is drawn over a driven slitter roll where the edges are trimmed to remove the uncoated edge and small beads of plastic which builds up at the edge of the film. In continuous operation, roll of material is unwound. New rolls are automatically spliced on the fly, and when required, the surface of the substrate is prepared by chemical priming or surface treatment to make it receptive to the extrusion coating and to help develop adhesion between the two materials. Pressure and temperature on the web and extrudate combine to produce adhesion. In this diagram you can see how the coating is done by extrusion process. This is the base or substrate material which is taken from the roll, and it is passed to the two rollers in between, chill roll and here one more roll, nip roll it is been called. From the extruder, this is the extruder, raw material like LDPE, that is low density polyethylene, HDPE, high density polyethylene, then say any other suitable material can also be charged here, and in the extruder it is been melted and the molten material is going to pass through this type of dye arrangement. This yellow shaded portion is the plastic material which is emerging out of the dye. This is a long dye through which the plastic is coming down, and it is placed over the web of material, and it is both are passed through the chill rolls where this plastic molten material will be solidified, and when it is going to pass through the nip rolls, it is going to fix onto the substrate, and then it is wound over the rolls. As we could see, this way the extrusion coating is done. This cooling has to be accomplished in about a half revolution of the roll, thus necessitating very efficient water cooling of the roll. The chill roll is also determines the surface finish of the film. For high gloss, the surface of the chill roll must be very highly polished. Where dull film surfaces are required, chill roll may be etched or sandblasted. This is again the similar arrangement where this is the extruder onto which the coating is done on the base of a base or web material. So this same method is adopted even this kind of arrangement where the coating is done. Co-extrusion. Co-extrusion is meant for multiple molten layers. How these are multiple molten layers are obtained, for which we have to make use of co-extrusion line. Co-extrusion provides number of layers, usually using one or more extruders with a melt going through one die that are bonded together. This technique permits the use of melt heat to bond the various plastics or using the center layer as an adhesive. Co-extrusion is an economical competitor to conventional laminating processes by virtue of reduced materials, handling cost, raw material cost, machine time cost, and pinholing is also reduced with co-extrusion. Even when it uses one extruder and divides the melt into at least a two-layer structure. Other gains include elimination or reduction of delaminating and air entrapment. In this table, you can see the compatibility between the plastics for co-extrusion. Say here numbers what are shown. One is one layer, which is layer is easy to separate. Two means layers can be separated with moderate effort. Three means layers difficult to separate. See, LDPE is the best material for making the multi-layers extrusion, co-extrusion, because it is the number 3. So 3 layers, we that delaminating will not take place. Bonding will be excellent. That is why LDPE is the best. HDP is also best. PP material is also is the best material for making the co-extrusion of laminates. Then ionomers are better, even like nylon, EVA can be used. EVA itself with the 3 layers with the LDPE combination we can make use, or HDP combination as well as PP with we can make use. So with different materials can be used to form the different layers. So multi-layer extrusion can be done. In this diagram, you can see here the first station of lamination. Here substrate is passed through the nip rolls, onto which substrate of another type is passed here. In between, the molten material which is emerging from the extruder is shown over here. Raw material is fed here, melted in this extruder. Then it is going to pump through the die and it is coming out. And this molten material is now going to pass in between the two layers of substrate, and this will be carried further with this idler pulley. Now this when passes to the next station will be completely cooled and solidified. The plastic material will be solidified in between two layers of substrate. Now again it is passed through another set of two rollers, nip rolls. Here plastic material from extruder B and extruder C, when both extruders function is same, to melt the material and to pump to the common die, and it is material comes out and it is passed in between the previously prepared the laminate with the another substrate, that is the third number. This substrate is the on top layer, and here the plastic molten material, it is going to spread into in between, and when it passes through this idler pulley and the nip roll will be cooled and this will be taken out. So lamination can be carried out like this in single stage or in multi-stage stations, multi-stages, so that required thickness and of a number of layers laminates can be produced. What are the defects? Of course, we cannot manufacture the product as 100% excellent. Our motto is to produce the better quality products. Of course, there will be some defects or some troubles we may have to face during the production. Important prerequisites to an efficient problem-solving process are: we should have the good instrumentation. That means to read the parameters, set the parameters, and of course to maintain the required parameters, for which we need good instrumentation. Good understanding of the extrusion process is also very important. What stage, what temperature must be, and how, what is the speed of the takeoff and extrusion, all these are important. Collection and analysis of historical data. We have to collect the sample, we have to do the analysis, we have to find out, we have to match the result or compare the result of the previous say production, so that we can overcome if at all there is a problem in the production. Team building. This is the team, not as the individual. We have to make a efficient people's team, so that any problem will be get solved by discussing each other. Good information about the condition of the equipment. We should have the technical know-how. Similarly, about the machines also we must be well versed. The machine is, if it is not in good condition, the product may not be of the good quality. If some breakdowns comes or any kind of the machine problem comes, then we will not be able to produce the product. Good information about the feedstock, that is also more important. Now, the extrusion process is to a large extent a black box process. It is not possible to visually observe what goes on inside the extruder. We can see material going into the extruder and material coming out of the extruder die. However, what happens between the feed opening and the die exit cannot be seen in normal extruders, because the process is obscured by the extruder barrel. Therefore, we are largely dependent on the instrumentation to determine what happens inside the extruder. We can think of instrumentation as our window to the process. Because it is very difficult to determine what is happening inside the extruder without instrumentation, successful problem solving requires good instrumentation. It is not sufficient to have ample instrumentation on extruder. It is also important to confirm that sensors and readouts are working correctly. For instance, if a temperature zone along the extruder is showing an excessively low or high temperatures, we should verify that the temperature reading is correct. Sometimes the false reading it may show, or the heater might be on, but actually the heating process is not taking place. That may be the problem. So instrumentation is essential, but cross check is also very important. The measuring instruments must be correctly calibrated, and we should establish that the instrument is capable of measuring the variation of interest. In statistical process control, specific procedures have been developed to determine the capability of the measuring instrument. Now let us discuss about what is a reaction injection molding process. Reaction injection molding process is a advanced type of process in which we can say produce the product by reacting the raw materials in the mold. Say this is the mold into which the raw materials from separate arrangement we can mix them together, and we can pump into the mold, and cooling is done. We can by opening the mold you can produce the product. Now let us see in detail. There have been for many years number of molding methods in which the plastic material is manufactured at the same time as it being shaped into the final article. It is only recently that this concept has been applied in an injection molding type of process. In reaction injection molding, liquid reactants are brought together. They just prior to being injected into the mold, and in the mold polymerization takes place, which forms the plastic at the same time as molding is being produced. In some cases, reinforcing fillers are incorporated in one of the reactants, and this is referred to as reinforced reaction injection molding. Since the reactants have low viscosity, the injection pressures are relatively low in the reaction injection molding process. Thus, comparing the conventional injection molding machine with a reaction injection molding machine having the same clamp force, the RIM machine could produce a molding with much greater projected area. Therefore, reaction injection molding process is particularly suitable for large area moldings such as car bumpers and body panels. See, polyols and isocyanates, these are taken separately and they are pumped, and they are mixed at required proportion. Additives volatile required are pumped into the same mixing unit, and the material will be pumped into the closed mold, and after filling the mold is cooled and the mold is open and the product is ejected out. So here, instead of pumping the molten plastic material, we are going to take the reactants which will be going to produce a polymer, and they are pumped into the mold. Their polymerization takes place and the solid product of the required shape will be going to produce in the mold. This way the process is conducted. Now it is the time to discuss about multiple choice questions. RIM stands for A. Reaction injection molding, a rapid injection machine, reduced injection molding, a repeat injection machine. RIM stands for reaction injection molding. Just now we have come across about this RIM. Injection pressure is relatively low in RIM process due to dash. Answers: A. Thick molten material, B. Low viscous reactants, C. Low melting temperature, D. High melting temperature. The correct answer to this question is low viscous reactants. Hence, injection pressure, whatever required, is comparatively low in RIM. Question number 3. Raw material for pipe extrusion is dash. Thermoset resin, B. Thermoplastic material, C. Fiber, D. Adhesive. So correct answer is B. Thermoplastic material. Raw material for pipe product extrusion is thermoplastic material. Question number 4. Co-extrusion provides dash layers. Co-extrusion provides single layer, multi-layers, no layers, none of this. Co-extrusion is meant for multi-layer production. Question number 5. Cast film is extruded through the extruder using dash die. Circular die, oval, slit die, pipe die. Cast film is extruded through the extruder using slit die. Third answer, C is the correct one. Question number 6. Cast films are dash than tubular film. A. Cheaper, B. Costlier, C. Better, D. None of these. Correct answer is costlier. Cast films are costlier comparing to tubular films. Question number 7. Fibers are produced by using the die called dash. Spinneret, B. Straight die, C. Circular die, D. Breaker plate. The correct answer is spinneret. Fibers are produced using the die called spinneret. Question number 8. Commonly used raw material for wires and cables is dash. A. HDPE, B. Natural rubber, C. Resin, D. PVC. PVC is the correct answer. So, commonly used raw material for wires and cables is PVC. Thank you.